All right, welcome back to Weigh the Wrench, and on today's very special episode, we are now installing the main event. We are installing the mechanical toys that everybody has been waiting for. What I'm talking about, solenoids. I am super excited, so let's go. All right, so first off, before we start the video here, there's a couple things that are gonna come up quite a bit in the comment section below, and there also have been coming up in the forums all the time for the last couple of years. And the one question is, if we've already got a surround sound feedback kit set up in this virtual pinball cabinet, why are we adding solenoids? So first thing is, if you are building a virtual pinball, I think it is a requirement to have a good SSF system. It is night and day, and to be able to hear the sounds and feelings vibrating through the cabinet, it is a must. So install that. And if you don't know what I'm talking about, I will post a link above for the video so that you can go figure out how to do that. Now, why are we adding solenoids? It is a lot like all the other real mechanical toys we have already installed. A real gear motor, a real knocker, a real shaker motor, blower fan, and now solenoids. They all add a little bit more depth to the feeling and the sound of the experience of playing virtual pinball cabinet, and it gets it that much little closer towards it feeling like a real pinball cabinet. So that is why we're adding the solenoids. And the second question that comes up is, why are we using solenoids? Can we use anything else? So there are a few different ways of making a mechanical clunking sound happen underneath your monitor, which is supposed to represent your pop bumpers, your slingshots, and your flippers in a real pinball cabinet. So the first method of making those clunks is using an automotive starter solenoid. So an automotive starter solenoid basically uses a little bit of electricity to cause the internals of the solenoid to move a contact over to engage a high amp circuit, which starts your car motor. And when it does that, it makes a mechanical clunk sound. When you take the power away from the solenoid, it returns back by a spring and makes another clunk. So it sounds and acts a lot like a flipper mechanism. So that's why people like using them. Now, pros for these starter solenoids are they're pretty cheap. You can get them for about $10 to $15 each. However, the cons on this is this part is not designed to be activated so many times so frequently, and it's not meant to be kept on for long amounts. So if you're holding your flipper button, that can cause these to wear out. Now, the second method is to use industrial electrical contactors. Now, these are basically the same thing. We're using a little bit of electricity to engage a higher amperage circuit. However, these are not used in cars. They're used in more like industrial warehouse kind of settings or factories. Now, from pros for these, they do sound a little bit more clunky, more powerful sounding, more vibrations are felt, and that's generally because we have a 24 volt or maybe even up to 48 volt power supply driving those. Now, the con is you're going to have a power supply to drive those and install it into the cabinet, which is added cost. And the other thing is these contactors are not cheap. They're going to be more expensive, but they do hit a little bit harder than regular automotive solenoids. And a third way of doing it is, well, if we're trying to simulate real pinball parts underneath our monitor here, why don't we actually use real pinball parts? What a great idea. So the pros for this is it literally will sound like a real flipper and a real pop bumper because they are the actual parts underneath the cabinet. That's a pretty big pro. Now, it's also got some very big cons. The very first thing is you are going to need, once again, a higher power supply to drive all that, something like up to 48 volts sometimes. So you're going to have to install that and the cost for that. You are also going to find that those real pinball parts are quite expensive. They're going to be probably about 50 bucks each. So once you total them all up, you might have upwards of $500 of real pinball parts. Now, another con, which is kind of defeats the purpose for virtual pinball, is you now pretty much have a real pinball machine, and you're going to have all the maintenance and repairs in the future when these parts start to go bad. So there's some things to think about, but if you want the ultimate, probably best sounding, then you're going to want the real pinball parts. And one thing to think about, when you start getting up into 48 volts, either with the contactors or the real pinball parts, you have to keep in mind that you now have safety issues where if you've got the power on and you're inside the cabinet, you could literally touch something and kill yourself. So keep that in mind too. And then there's a fourth option, which is what I'm going with, and it's kind of like a mix between the two and the best of both worlds. So let me show you what I'm going to put in. So these are open frame solenoids, and this is a kit from Cleveland Software Design, and Philip has put in some extra work here to try to make some solenoids that are even better than any of the other automotive relay out there. Now, the reason why these are better is he has specially produced these to be well over 1 million hits or cycles of use before having any issues, so they're meant to last a long time. The fact that they are open frame means that the coils can get rid of the heat that is created when we use these. And the other thing is there is a bracket or a striker plate that is adjustable on the side here so that we can actually modify the sound of how hard that hits and make our solenoids sound a little bit different or harder or quieter, whatever you would like. Now, the other really cool thing about this is these life extender boards. So we've previously talked about how if you hold the flipper button, you are going to be engaging one of these solenoids to be holding out. That way, as soon as you let go of the button, it comes back and makes the sound coming back. However, when you're holding one of these solenoids out like this, it causes these coils to heat up and eventually break the solenoid. So these life extender boards, how they work is when you go to initially hit the flipper button, this is going to be a nice loud crack, full 12 volts power. And then we want this to hold, but we don't want it coming back yet. And so what it does is it drops down the hold voltage to something about 2 to 4 volts. It's actually adjustable with the little blue potentiometer on the board. And that way you can make it so that it's just holding it out enough that we're not using any other voltage, and it'll make these things last forever. Now, there also is a little jumper on these boards that allows you to adjust the length of time that it has full power when it first engages. So if you want it to hit a little harder or a little softer, you can change the jumper as well. So very slick setup, and his kit, once again, is a great plug-and-play kit. Comes with wires already mounted in the connectors here. So if you're working with a pin 1 setup, this is just literally plug and play. And he does have these open frame solenoids mounted on some boards here. The screws are ready to put in, so it'll be very quick. Now I'm going to go the extra little mile and take these open frame solenoids and the extender boards and mount them in special places in the cabinet like you're going to see, just to get that extra little bit of exact placement where these should be. I want them exactly where a flipper would be, where a slingshot would be, where the pop bumpers would be, etc. But some of you may not even notice that difference, so if you just want to screw this into the sides of your cabinet in the right locations, that'll work for you too, and it's already nicely set up for you. And these life extender boards have a little fuse already built in, so if something's not right or we're using something too much and something wants to burn up, it's going to blow the fuse instead. We're also going to use a fuse inside on the grounded switch side on our MOS 8 boards, so this is going to be all fully protected. Now on these life extender boards, the input's pretty easy. We've got a plus sign, that's where we're going to get our 12 volt power from our power distribution block, and then the numbers 1, 2, 3 refer to the 1, 2, and 3 open frame solenoids that we're going to use, and those are going to be our switching ground wires that are coming from our MOS 8 board. And then on the output side, you can see it's all numbered. So number 1 solenoid, there is a negative and a positive wire, and then number 2 solenoid, negative, positive, and number 3 negative and positive wires. So pretty simple to set up. And then because I'm taking these life extender boards off of the board that comes in the kit, I wanted something cool to mount them inside my cabinet. And once again, thanks again to Luke Oliver for these custom STL files to be able to hold those boards. There is a file for the 2 solenoid life extender boards and the 3 ones. So in my case, I've printed them out already. Thank you very much. I will put a link down in the video description so that you can find these yourself. So the next couple things that you got to think about is how many devices are you putting into the cabinet and where are you putting them in the cabinet? Ultimately, we're trying to position the sounds, that mechanical clunk, coming from a certain area where those parts would be operated from. So if you only have 2 of these solenoids, then you're probably just doing flippers, and you would mount them somewhere or as close to where the flippers would be in real life. If you wanted to have 4 solenoids, then you could add 2 to the side to represent your slingshots, and a couple more, and you could start simulating where pop bumpers would be. Now, when you start getting to pop bumpers and other slingshots and drop targets and things like that, every pinball table is a little different. So where do you place the stuff? Well, if you want to go with a 10 solenoid setup like I'm going to, then you can tell DOF where those solenoids are, and then when it knows that a sound is in this area, it will trigger that solenoid. So that way, if the pop bumpers in one game are up here and next time they're over here, they can operate wherever they are to simulate the best effect. So for me, I wanted the best experience possible, so I ordered the 10 solenoid kit. So that's going to allow me to put 2 on this side of the board where the flippers would be, 2 on either this side of the board or maybe even on the side to represent the slingshots. And then I'm going to put 3 in the middle of the playfield, so a left, center, and a right, and then 3 on the rear left, middle, and right, and that way I've got everything in the right spots, and DOF can take care of where that sound needs to come from. Now, I don't even know if this is going to make a difference. However, I am going to go the extra little mile and mount these open frame solenoids in the way that the direction of force would be applied in a real pinball cabinet as well. So for example, pop bumpers, they're going to be up and down force motions, so those open frame solenoids are going to be mounted vertically, whereas something like a slingshot would be sideways. Now I've set this adjustable striker plate to the maximum amount of distance. So I kind of want to make it as loud as it possibly can first. And if it's too loud, then I can always bring this down to lessen the distance it has to make a sound. Or if I want to change that maybe the slingshots aren't as loud as the pop bumpers, etc., I can do that as well. Go ahead and disassemble all the other ones too. All right, let's get these installed in the cabinet. Right, there's the flipper solenoids done. Okay, that's the slingshots done. All right, cool. So these solenoids are all installed, and now it's time to wire them up. So these life extender boards have a positive next to the 1 and 2, or 1, 2, and 3. The positive is going to get 12 volts positive coming from our power distribution block. And then the numbers 1, 2, or 1, 2, and 3 are each going to get their very own port on this MOS 8 board. So we're used up to port 4. So we're starting with port 5 on this MOS 8. So we're going to make this port 5, port 6, port 7, port 8, port 9, port 10, port 11, port 12, port 13, port 14. So let's go ahead and wire this up. Okay, to make the wires look a little better, I'm going to be using those Stay Geek wire management systems again, just to kind of make it look a little better, and might as well put it on first, that way we can route the wires in there. And we might as well use the wires that came pre-set up from Cleveland Software Design. All right, so the green wire is the positive. So I'm going to unravel this so I can get it to my power distribution block. Something like that. My number 1 is my blue wire. So back left, or blue, is getting port 5. And number 2 in the back is yellow. Port 6 is getting the middle back. And the white one, which is right back, is getting port 5, 6, 7. And once again, green is our positive, so I'm going to unravel that to get it to my power distribution block. So this is for the middle life extender board, or the center. Probably end up cutting these down too. Now, this one, I am going to have to take the blue one off to get it to here for port 8. All right, route this one up. So the center left solenoid, or the blue one, is going to be port 8. All right, with this yellow and white, we got to transfer it over to the second MOS 8, and we're going to use ports 1 and 2 on the second MOS 8. Okay, so the middle center solenoid, or the yellow wire, is going into port 1 on the second MOS 8, and then the center right solenoid, or the white wire, is going into our port 2 for the second MOS 8, which in the Dude's Cab configurator is going to be ports 9 and 10. All right, slingshot solenoids. Once again, green is our power, positive. So we're going to unravel this, and that is going to get put to our power distribution block. And then we've got yellow, which is going to be port 11, and the white one is going to be port 12. Okay, and then once again, the left and right flippers, we need the green for our positive. So we're going to unravel this, and this is going to go to our power distribution block for positive. Then the left flipper is the yellow wire, which is port 13. And then the right flipper is the white wire, which is port 14. Don't forget to put one of those 5x20mm glass fuses in your MOS 8 boards for each of those solenoids that you just installed. Now, I talked to Philip. He says those solenoids will use 3.5 amps. So we're going to put a little bit of a safety buffer on there, and we're going to put in 5 amp fuses. All right, we've got those open frame solenoids from Cleveland Software Designs all installed very nicely and professionally looking. We've got all the wires run and set up to our MOS 8 boards. And there's something to be said about just really nice, clean, organized layouts. It's going to be easy to figure out what's what here. So let's now open up the Dudes Cab configurator and add these ports into our output boards, and then we can double check and make sure that we are using the right solenoids for the right areas where we have mounted them. All right, so we're going to open up the Dudes Cab configurator. Is Dudeness. Okay, we're going to connect, and then we're going to go to output cards. Now, if you don't know what's going on in here, I do have a video where I installed the Dudes Cab, and I will put a link above for you to watch so that you know what's going on here. So, output card, and we are now going to select port 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 for our 10 open frame solenoids. Then we're going to scroll down. And then starting with 5, we're going to label this rear left solenoid. Now we can leave this as custom, but there is something here that I did want to talk about. So we talked about how these open frame solenoids and the CSD life extender boards have the hold voltage, so that when you're holding a flipper button, it will reduce the voltage and help make the solenoid last longer. So flipper logic in here will allow you to do that. So you can actually change some settings in here to have it drop down in voltage and save your solenoids and last a little longer. So, but for us, we've already got that built in, so we are going to just we could use contactors if we wanted, but I think we can literally just use them as custom as well. Okay, now we are definitely going to want night mode. These things are going to be noisy, so we want to be able to shut them off if we want. And then we're going to continue down doing all the rest the same. 6 is going to be our rear center solenoid. Port 7 is going to be our rear right solenoid. Port 8 is going to be our middle left solenoid. Port 9 is our middle center solenoid. Port 10 is going to be our middle right solenoid. Port 11 is going to be our left slingshot. Port 12 is our right slingshot. Port 13 is going to be our left flipper solenoid. And lastly, port 14 is our right flipper solenoid. All right, now at this point, we are going to send config. We're going to save to memory, and now we can actually test this. So what we're going to do is we're going to open up the monitor while I'm recording this and go through individually each one and make sure that it is, when I click the right solenoid on here, it does the correct solenoid inside the cabinet. That way I'm not worried about why it's not working properly or sounding properly later in DOF. Okay, here's our very first test of one of the solenoids. Cool. And we don't really want to have it on here. We can leave it on, but don't leave it on for too long. You're going to want just to use pulse. Cool. All right, so let's open this up and double check that it's the right solenoids going off for the right port on our Dudes Cab here. Okay, here we go. Port 5 should be this one right here. Yeah, that's correct. Port 6 should be the rear center. Yeah, awesome. Port 7 should be our rear right. Perfect. Okay, port 8 should be the middle left solenoid. So this guy here. Awesome. Middle center should be this one. Nice. So far so good. Okay, port 10 is our middle right solenoid, so the one on the other side of the cab. Awesome. Okay, now we've got our left slingshot, which is this one here. Oh, I've got those reversed. Okay, this is why I wanted to test this, so we're going to switch this off camera. And if I do the other one, it should be the other side, so right solenoid. Okay, we're going to have to switch those, so I'll do that off camera. And then we got left flipper. Okay, that one's correct. And right flipper. Sweet. Okay, so I just have to switch the wiring between these two, and then we're good to go. All right, so off camera, I've switched those two slingshots, and now I've double checked them. They work perfectly, and I'm pretty happy with the nice clunky sounds I'm getting. Can't wait to see this in the game. So the next thing we have to do before we get out of here is make sure that you press send config and save to memory to save what you've changed here. Go ahead and kick out of this. And then we're going to go to our old faithful VPU config, and we're looking for the DOF config tool. So this is it here. Okay, click on anything over here to get it to initiate to put in your sign in. So go ahead and sign yourself in. All right, make sure you are on the right cabinet, and then you're going to come over here, click on cabinet, and if you haven't already, you're going to have to go to devices and put in the dude's cab. We've already done this in a previous video where we installed the gear motor and the shaker motor and the knocker and the blower fan. So go check those out first. And then once you got that dude's cab in there, you're going to go down to port assignments. Then you can come down here with this pull down, left click on it, make sure that you are on the right part. So we want the dude's cab. And now we just got to input all of these solenoids and tell DOF which one is which. So starting at the back left, port 5 is a 10 bumper back left, 10 bumper back center, 10 bumper back right. Port 8 is going to be 10 bumper middle left, 10 bumper middle center. Port 10 is 10 bumper middle right. And we've got slingshot left. Port 12 is slingshot right. And 13 is going to be our flipper left. And last one is 14, which is flipper right. Man, this is so simple. Awesome. Okay, we're going to go up here. We're going to update this. And then the last thing we have to do is we have to generate a new config. So click generate config. Okay, once that's done, go to where your download is. We're going to open this up. I'm going to left click and drag over all these guys, right click copy. And then we need to go to this PC, C drive. And then we're going to go to direct output, and those are the same files here, so we're going to right click and paste them here, and it's going to say, are you sure you want to replace them? Sure do. And there we go. That's that. Now the last thing we need to do is we need to go to C drive, vPinball, visual pinball, and we're going to scroll down to our vPinball X, which is our default controller that we have set. And we're going to have to make some changes to tell DOF whether we're putting in just sound effects or DOF only, etc. Now, we're only going to show you how to do this one, but if you're using any of these other versions, you're going to have to go in and make the changes there as well. So open up vPinball X, and we're going to go to Preferences, go to Configure Keys, Nudge and DOF, and then over here, we are going to select what we want to have happening for sounds inside our cabinet. Now, we're going to start with here with flippers and play just the DOF, so just the solenoids activating. So I kind of have a feeling that later in life I'm going to be setting it to both, but for now I'm going to put it on DOF only just to hear the difference. Now, I notice it doesn't say solenoids here, but it does say contactors, and those are what we would be changing in this thing. So I am going to change it here for contactors to DOF only as well. Targets and drop targets, we have the same setting here. We can turn it to just DOF. Then we can turn it to DOF, and then we can do drop targets also as DOF, and then we'll see how it sounds. We may come back and put both later. Okay, once you've made your changes here, you're going to press OK. Close that out, and we can now start this up in Pinup Popper and hear our very first solenoids in action on this virtual pinball machine. All right, very cool. These are very nice and snappy and loud sounding. And there's no mistaking that there are real mechanical parts moving around in here. I am noticing though, I am getting a little bit of false nudges happening. You can see on the ball here. Nice. Okay, slingshots are definitely working. Nice. Sweet. Let's get some pop bumpers in here. Nice. Pop bumpers are working. Slingshots are working. Awesome. And I'm feeling a big distinction between where the sounds are coming from as well. Yeah, you can definitely hear the sounds alternating between left and right and center. Awesome. All right, so I've been playing some games in the background and I'm pretty happy with the sound of these open frame solenoids. They are sounding like perfect pop bumpers, and anything in the middle and the back sounds great. The slingshots sound really good as well. However, the flippers, maybe it's because they're right in front of me, or maybe because they are metal on metal, there is kind of like this really clacky metal sound, like this. So it's a little too loud in my opinion, and it sounds like metal hitting metal. And I just happen to have my Paul Bunyan 68 pinball machine here. This is a real pinball machine, and it's still loud, but it's not as metal sharp kind of snappy sound. So something's mechanically moving in there, but it doesn't have that clack of metal on metal. So I'm going to adjust the striker plate, go a little bit closer so that it doesn't have as far to move before it hits. And if that doesn't make a difference, then what I might do is put it right back to its original length and then put something in between there so it's not metal hitting metal, but maybe there's a piece of rubber to kind of have that motion, but not so loud and clacky sounding. And the other thing I've noticed, that the solenoids that are responsible for the flippers are making the cabinet vibrate too much. So if you look at the ball there, so I'm going to try that and see if I can get rid of that false nudges happening to the ball, and then go from there. So I've shortened the distance on the left flipper only, so that way I can try this again and listen to the difference between the left and right and see if the left doesn't cause any of those false nudges. Okay, this is the right flipper that was unchanged. And this is the left flipper with a little bit shorter distance. So it's almost there. You can hear there's definitely a change, but it's still hitting the nudge on the ball, but it's a lot less. So this is a good part of the video for you guys to realize how it's going to sound differently where you put it on the striker plate. So this is the furthest away, and this is one notch closer. And I think since both sides are still having false nudges, I really am happy with where my Dude's Cab is calibrated for nudging, so I don't want to mess with that and start adding dead zones and stuff. And really, this is kind of an experiment in how to place your solenoids, because if you remember when I made those shelves, I was fully intending on putting all those solenoids facing straight up and down. And when the backs go off, there is no vibrations, false nudges, but on the fronts, I've turned those sideways, and those are definitely adding those false nudges. So I think I'm going to take the slingshot solenoids and the flipper solenoids and turn them 90 degrees and face them straight up and down and see if the nudges are still there. And I'm also going to change the length on that striker plate on the right flipper. Okay, I've got the flipper solenoids now pointed straight up, and I've got the right flipper striker plate brought in to the same as the left, which is just one notch in closer. Here we go. All right, way less nudging. In fact, it's pretty much negligent. Awesome. Okay, I'm happy with that. And these are still quite loud. Might be a little louder because the glass is off here, but I'm happy with the sounds, and no nudges, so my nudges is going to be still good. Awesome. Okay, and while I'm at it, I'm going to turn those slingshot solenoids straight up and down as well, so we don't have any extra nudging from them as well. Okay, here's the new position for the flipper solenoids and the new vertical positions for the slingshots. Now that you have all of the solenoids installed, it is up to you if you want to just leave them with the solenoids all sounding the same, or if you want to start tweaking with them to try to make them sound a bit different. So for me, when I hear the flippers and the slingshots and the pop bumpers all sound like that metal twack sound from the solenoid, kind of dispels the illusion that it's actually different parts. So for me, I've tried to mess around with the things and try to get them to sound a little different. So whether you are putting no striker plate on it, or you're putting the striker plate to the furthest extent, or you put it a little closer, or you could also put some material on the striker plate. So what I've done on my slingshots is I've put some 1/8 thick rubber matting, and I've attached that to the striker plate, and it's giving it kind of more of a dull thud kind of sound now, rather than the snap of metal on metal. And to me, I think that sounds a lot better. And on my flippers, I've got the striker plate a little bit closer, so they're not just as crazy loud. And then the pop bumpers, I've left basically the furthest striker plate distance. And so for now, I think this is pretty good. I might tweak it a little bit later in the future, but to give you an idea of what it sounds like, I've got another great game that I've been playing lately. It's called Starlight. It's a very rare game. There's only like 100 made, probably less than 50 around. And we can little gameplay and you guys can hear what they sound like. All right, here we go. Starlight, similar music to Laser Cue is probably why I like it. Basic premise is you're collecting stars and constellations. Here we go. Top inlanes get lit up by lighting the rollover switches on the playfield or on the top inlanes, and you can move those lights with the right magnesave. There's only one right magnesave. That saucer gives you 3,000 per light. And by completing the targets for star, you get a 2-ball multi-ball, which is brutally hard to keep going. And by collecting the targets for light, you can light your spinners. There is also a roaming multiplier that moves. So you can get your 2 times and 3 times. Okay, we just need T. Yeah, we got another oh, we had the 10 times multiplier. Nice, 549, that's a good first ball. There we go. Whew, that was fast. Okay, there's the lock for our 2-ball multi-ball, and as soon as the other ball hits a switch, it'll start. It is a brutal 2-ball to keep going. I'm not sure why, but it is. Oh, come on now. Oh, there he goes. That was actually one of my better multi-balls on this game. See if we can nail this spinner. Oh, there we go. 1.27 million. Nice. Last ball. Oh, that's okay. 1.375 million. I'm okay. Oh, there goes our knocker. I'm okay with that. 1.37 million. If you haven't checked out Starlight, give it a try. It's an amazing game. All right, let me leave you with one final thing. So in the typical way of the wrench fashion, I am going to try to think of absolutely everything that you might need when you do this modification to your cabinet. So you have your games working properly with your flipper buttons using solenoids, but what about when you're in the pinup popper menu and cycling through tables? Wouldn't it be nice to have the actual solenoids for your flippers and the back solenoids working for your MagnaSaves? Well, if you want to know, this is how you do it. Okay, once again, type VPU config and go to the home config tool website. And then you're going to scroll down, and where it says table configuration section, click on that. And then what we need to do is actually bring up the table for the pinup menu. So scroll down or grab the little slider bar till you get to P. And here it is here, pinup menu. So it's kind of like calling it a table, but this is for the pinup popper menu. Click on that. And then if you scroll down, you're going to go to where it says flipper left and right. And really, to be clear here, there is the public configuration. Do not modify anything on this side. You are only doing your user configuration. Okay, this is your own personal stuff. Don't mess up the tables for everyone else. Okay, so what you do is you go down to flipper left, and you go over to your side, and you type in E800, and that refers to using the left flipper button. For the right flipper, you're going to type E801. Okay, and then if you've got the 10 solenoids like I do, you're going to find the back left, and we're going to type E805. And then we're going to go to the back right and type E804. And then, so these are for your left and right MagnaSave buttons. And so basically you're saying whenever you press this MagnaSave button, we want to trigger the back right bumper or the solenoid. So the flippers are used for scrolling left and right through the tables. And then the MagnaSaves in pinup for me is scrolling to the next letter of the alphabet. Okay, once you've done that, scroll up to the top, press update, and then you have to generate your config again. Okay, and then you go to your downloaded folder where it is. You can double left click on it, left click and drag and copy, right click, copy it. And we're going to go up to C drive, direct output, right click paste, and yes, you want to replace what's there. And then we can close this all out. And let's give it a try. Now there is an issue. Same thing with the LED matrix. It doesn't work for about 10 seconds. So there it goes there. So at the same time that you'd have your LED matrix kick in is the same time that you're going to have your DOF kick in for the left and right flippers. So this is the left and right flippers. So you can really hear that. And then if you use the MagnaSaves, it's the solenoids at the back cabinet. And because I left the back ones at full extent to the striker plate, there's a different sound, so that's kind of nice that there's a distinction between the flippers and the MagnaSaves. So just another thing to add to your customization for your vpin to make it exactly how you like it. So some of you might not like how loud that is and you're used to the SSF doing pinup popper, or you don't like that little 10-second delay that is in pinup popper for DOF to work. So if you don't want to do that, then don't just put in those E codes like I just showed you. And man, if there's anybody out there, can we figure out how to get rid of that 10-second lag, 15-second lag? I think someone needs to work on that, and it is above my pay grade. All right, that's a wrap in another video from Way of the Wrench, this time on how to install your 10 open frame solenoid kit from Cleveland Software Designs. Special thank you to Philip for providing those parts for this video. And man, oh man, is this virtual pinball really starting to feel like a real pinball, especially with all the real mechanical toys and stuff going on underneath. What's next? We've got 2 spots left in that Moss 8 board, so I'm kind of thinking it would be neat to make a video for you guys so that we can show you how to light the buttons of the front of the cab and get them to flash for like start and for launch when it's needed using DOF. So stay tuned for that video. If you haven't already, why don't you join us on Instagram? That way you can check out what's going on in this amazing shop in between videos. Until next time, take it easy.